Hello to everyone. This is the activity for the lab number 3, data summaries. So remember, you can find this file, Word file, on Blackboard in the folder corresponding to the lab. You will have there this file and complementary files, okay? And Minitab, remember that Minitab, I already have it here open, but I showed you how to do it in the first lab, I think, if I'm not wrong. Anyway, you have instructions in the first folder of the course. You have instructions to download Minitab. Actually it's an application from the web, and I think that you already know how to use it, right? So I already have this open, so let's follow and let's try to do the activity. Okay, the commands and important information you should know. All right, so first we have the title is lab number 3, data summaries. We have the introduction, we have categorical data, numerical data. Well, that is something that is covered in the corresponding video notes for this week. And the lab, let's go to the section of lab. Here we have the lab today consists of 2 different data sets for which we will do a data exploration. For each set, you will describe the data with both graphical and numerical summaries and then make conclusions based on the findings. The first data set is elderly health data set. And what is that? Well, I'm moving to Minitab. I don't have the folder here, but anyway, I don't have the file here open, but you are supposed to download in the complementary files folder from Blackboard. You're supposed to download the next file. Go to open, project. I have it here in my computer, local file. And then here, complementary files. This is the name of the file. Note it is Data Summaries Lab Workbook .mpx. That is it's the extension to identify a Minitab project. So open it. And here I'm going to put continue without autosave. Okay, and notice here in the bottom, in the very bottom, we have 2 tabs. One with the worksheet Elder Health, and the other one for the second part of this lab. So by now we're going to be working with this one. Okay, here in the bottom, you see where the cursor or the arrow is, Elderly Everglades. So when you open the project, you're going to see this. Now, the first file is the first worksheet is Elderly Health. So let's see what we have to do. It says a study examine the medical records of elderly patients to determine whether there are differences between men and women in their calcium or inorganic phosphorus blood levels, both in millimoles per liter. Well, whatever that is. A Minitab file that contains both data sets has been provided. You see it here. And you're having trouble. Well, this is if you cannot open it. Data definitions. Look at the data set and define each variable as categorical or continuous. Well, here age. Notice age is given by several numbers. So I think age is numerical. So I'm going to put here. Well, it says here categorical or continuous. Should be. I know numerical variables are divided into continuous and discrete, but I want to put here numerical. So I'm going to choose M for numerical and C for categorical. Notice, you see, and C, H is numerical, sex is categorical. Lab, the variable lab, I think is categorical, right? It has only 5 categories, so No, it says only 5, 4, 4, has only 4, 4, 3. It goes from 1 up to 5, I think. So even when it has numbers, I think it's going to be categorical. Calcium is, I think this is numerical. And this one, iron or phosphorus, whatever that is, I think is numerical. And H group, I think this one seems to be categorical, right? So I want to put here categorical. H group, I think, is a group where the ages are divided. But here the age is numerical because it reflects on the ages for these persons. So we have this here. Now, let's see what we have to do, the operation we have to do. All right, first, categorical data, pie chart by sex. Let's follow the instructions on the drop-down menu, select graph pie chart. So, graph pie chart. Pie chart is almost in the very bottom. So here, pie chart. Here, select, it doesn't say the instructions here, but use counts of unique values. And then here, we're going to be able to create a pie chart by, in this case, only by categorical graph pie chart, categorical variable sex. Either type in the box provided or use the left column, all right. So we choose the sex. This pie chart works only for categorical variables. So we have a categorical variable sex, and then we click OK. And I think that's all. And there you have the pie chart for this variable. You see? We can see that number 2, I think, is women, and number 1 is men. So notice we have here a little more men. Well, now Mac instruction, we can skip this. Bar chart by lab. All of these techniques are going to be very useful when you do especially the second part of your project. So bar chart by lab, the same. On the drop down menu, select graph bar chart. Oh, by the way, the graphs are going to be everything what we're doing is going to be saved here in this column to the left. You see that? Notice we have done a pie chart, so it's given there, pie chart. So now we have to do bar chart by lab. So go to graph, bar chart. Here do you have? Leave the default selections of counts of unique values and simple. So here, counts of unique values. Simple, it says one variable, multiple variables with groups. So leave the default selections, all right. Categorical variables, lab. So we don't have to do anything else here, but only to do a bar graph for the lab. So we use one variable, okay, and then choose lab. You can double click, right, and then okay, and there you have a bar graph. You see that? Bars graph. Again, this applies only for categories, okay? So we see that the most common lab is the number 1. All right, now Mac instruction, we can ignore this. And then we have here some questions. Which sex, what the most prevalent? Report the proportions for both. Oh, by the way, if you want to know the proportions, all right, it's simple. Once you have the pie chart for sex, only put the cursor above each. For example, notice here for the pie chart, the red part, the proportion is 48.9%. I mean, this is as for women. For the blue part is 51.1%. So you can when you have to upload this, you can report those numbers there. Okay. Why did we use age group and not age to make the pie chart? Because age is numerical. Yeah. You have to respond this, but I'm going to put here because age is a numerical variable. And these pie charts, they work only for categorical variables. Categorical variables. All right, let's continue. Well, this is what you have to put when you upload the activity. Okay. Continuous data. We are in the same data set. Descriptive statistics. It says compute summary statistics for the data such as mean, standard deviation, median, quartiles. How to interpret those? They are given in the video notes for this week. For the numerical variables, these measures only apply for numerical variables. That's why it says here for the calcium, inorganic, phosphorus, and age. And then we're going to do that. Again, notice how here in the left column we have saved what we have done, the bars graph on the pie chart. So now we're going to do descriptive statistics for this variable. So go to stat, basic statistic, and display descriptive statistics. So we have display descriptive statistics, variables, we can put here all the variables for which we want to compute all this. By the way, here, well, let me select first the variables, C5, inorg, and age. Age, be careful, not age group, age. Age group is categorical, age is numerical. And here, you click here, here in this box, this button, the statistics, all right? You can see all the measures we can choose. I know many of them are not going to be covered here, and or maybe we will. I mean, I haven't explained them here in this course, but just in case you're interested in all of those, you have them here. But by now, we're going to leave the default statistics. Is that okay? Okay, and then okay. And there you have, see? The statistics, the n is the number of outcomes for each variable. The mean is the numerical average. The SE mean, ignore that. We're not seeing that here by now. The standard deviation, to understand what the standard deviation is, go to the video notes for this week. But the standard deviation essentially measures the variability in the data, in all the values of the data set. And then we have here the minimum, quartile 1, and the median, quartile 3, and the maximum. Remember, the quartiles, they try to measure the spread of the values, right? Again, if you want to see the interpretation for that, go to the book or use the video notes for this week. You will have to take that into account. But notice we have done all of this all at once for these three variables: calcium, inorganic, phos, and age. Part 2, graphical summaries. Make box plots of calcium and inorganic phosphorus by sex using the following commands. So here again, notice how everything we have been doing is saved here. Yeah, it's saved here. Now graphical summaries and make box plots of calcium, organic, inorganic. So go to graph, box plot is here, you see it almost in the middle, box plot, it said we have to choose with groups, but we don't have that option here. So you see, maybe the instructions are a little different. Well, that's why I think it's important that I do the video. I mean, the videos of the lab activities. But here we're going to choose one Y variable with categorical variables and groups. Is that okay? So let's choose this, and then okay. So we have graph variables calcium and inorg. So it seems to be may box plot of calcium or here. Well, I'm going to do it one by one. Is that okay? So first for the calcium, there you have, and then by variables, categorical variables for grouping, I'm going to use here sex. There you have. You see, in this box, the first one calcium, and the next one sex. And you can ignore this, and then okay. And there you have box plot of the variable calcium by sex. You see, by one man and two women. And this asterisk looks like an outlier. Now we do it for the other one. Graph, box plot, with categorical variables and groups. Okay. Now the other variable, the inorg, and the same by sex. So leave this in the same way, and we click OK. And now we have the one for this variable inorg, phosphor or whatever it is, and notice 1 and 2. See, two backplot for, but classified by the variable sex, one man and two women for both. Now, using the same command sequence, make the backplot for calcium and inorganic phosphorus by lab. All right, you can do that, right? Or you will have to repeat the process, but instead of using sex, you can do it for lab. I know, yeah, maybe I'm doing a little mistake here because maybe we can do all the backplot for both variables at the same time, but well, by now you can do like that. And make backplot of calcium and inorganic. Use the same command sequence, and now questions. You decide backplots to compare the calcium and inorganic phosphorus. To compare the calcium and inorganic phosphorus levels for men and women. Wait a minute. It's weird because it says compare side by side, but well. Well, this part number one, you will have to write down your conclusion. For that, you will need to remember how to interpret the box plot, right? That has to do with the five numbers summary, the quartiles. And the same here, which lab had the lowest? How do the means compare? Well, all of this you can respond to all of this, all right? You can use the interpretation that you see, or write down the numbers exactly. Again, all of this, the box plot has to do with the five numbers summary. That is the minimum, quartile 1, quartile 2, that is the median, quartile 3, and the maximum. So please check the video notes or the book for the reference of those concepts. So let me do the other one. Everglade water is the other file that is in this project for Minitab. Everglade water is this one here. You see? Everglade, Elder Hill, Everglade water. And we have the introduction here. Everglades National Park is the largest subtropical. Well, you can read all of this. Yeah, my focus on these labs is that we understand how to use the commands on Minitab, right? That is my main concern. So switch to the Everglades water tab. We have it here. If you are having trouble, oh well, this is, we can skip this. Now, graphical summary tool. What are we going to do here? Now we're going to apply other techniques, all right, to other variables from this file. Graphical summary tool. On the drop-down menu, select stat, basic stat, graphical summary, and then variable gauge height. This one. And it doesn't say anything else, so we'll leave it like that. Type OK. And there you have. You see that? And then it says repeat the process for each of the four other variables and report the center, spread, and shape. All right, you will have to do it for the other cases, but for example, for this one, gauge height, the mean is located here. Mean is negative 0.2879. Negative 0.2879. The median is here, negative 0.25. Remember, when the mean and the median are very close ones to each other, it's very likely that the shape of the distribution is symmetric, like this one, you see? Standard deviation, the measure of a spread, 0.6080. 0.6080. IQR, the IQR is the interquartile range. It is computed by using the quartile 3 minus the quartile 1. So in this case, it's going to be 0.22 minus the quartile 1, that is negative 0.755. 0.755, and the answer is 0.975. Yeah, be careful, because it seems here that the quartile 1 is a negative value, but the quartile 3 is positive, so you will have to do 0.22 minus negative 0.75, so it's going to be turned into a sum. So essentially will be 0.22 plus 0.75, and that's going to give you the width for the segment between the quartile 1 and quartile 3. And I put it here. How many modes? So this is going to depend on the shape of the distribution. If it looks like this symmetric, it's going to be only one mode. That's all what you have to put. And the skew direction is, you can put that skew to the left, to the right, or symmetric. In this case, it's going to be symmetric, you see, because it had this shape. Again, go to the video notes for reference about these concepts. So you will have to do the same for all the other variables: velocity, discharge, water salinity, and water temperature. And then you will have to respond for these questions. For which of the 5 variables in the set is more appropriate? Well, to use the mean, use here in this kind of question where you're using interpretation. It's not always like something like only one exact answer. So don't worry about so much about that. You can use your own criterion in this kind of questions. For the second one, for which of the 5 variables above is it more appropriate to use the median and the IQR at the measures of the center and spread? Again, just by understanding that you know how to interpret the meaning for the IQR and the median, you will have to respond to this question, right? All right. I think that's all by now with this activity. If you have any question, send me an email or just use schedule office hours. See you.